Good morning, student. Let's start today's class. In today's class, we are going to discuss about the solar thermal energy. That is, in previous classes, we have already seen what do you mean by life cycle cost? Okay, then annual life cycle cost. Okay, then present worth. Okay, Um so now in today's class we are calculating these parameters, that is life cycle cost, annual life cycle cost, okay, and present worth for solar thermal energy. Okay, now let's see. Solar thermal energy is mainly produced in solar thermal power plant. Okay, then the major component of this system, okay, to be considered in calculating life cycle cost. Okay, that is for life cycle, calculating life cycle cost of that system, the major components are heat energy collectors, boilers, okay, steam turbine, okay, electrical generator. These are the main components of this solar thermal power plant. Okay, and on the basis of these components we can calculate the life cycle cost. Okay, and the cost of the above mentioned components are listed in the following table. Okay, it is a it is just like one example. Okay, uh, so here we consider the heat energy cost is 25,000 per kilowatt. Okay, for producing the producing 1 kilowatt we use 25,000 for heat energy collectors. Okay, and the life period of that heat energy is, let's say, 20 years. Okay, similarly for boiler and steam turbine, 13,900, and the life period is 10 years. Okay, similarly electrical generator and accessories or tools. Okay, these these are the present worth. Okay, these are called present worth. Okay, now let us say interest rate. Let's the interest rate. Okay, I equal to 10%. Okay, that means why we use interest rate or interest, because one amount. Okay, the life cycle cost means the cost or the total amount required for maintaining or take caring of one system for their whole life period. Okay, whole life period means from for from the buying time to selling time. Okay, so for this period, let's say 20 years. Okay, for the 20 years, this 25,000. Okay, let's say first year needed 25,000. Okay, second year, uh, it is not constant that it need 25,000. Okay, because of in day to day life, or in 1 year to in year to year, or in our daily. Okay, the inflation increase. Okay, what is inflation? We have seen in the inflation increase, so that the value of money also decrease. Okay, that means in today's market, the value of 100 rupees, or the product which we the amount of product which we get from 100 rupees, after 5 years we get we get that amount of product, but it is not 100 rupees. It may be 110 rupees, or it may be 150 rupees. Okay, so the value of the uh, uh, money also decrease. Okay, so for constant for get the constant cost. Okay, in each year we use compound interest, okay, and for that we use interest rate, and let's say interest rate is 10%, okay. Then the life cycle cost per kilowatt is calculated as follows, okay. First of all, capital cost, okay. Capital cost, here capital cost means the present worth, okay. We calculate present worth, and that capital cost is equal to cost of all the components, okay. Cost of all the components, you see, 25,000, 13,900 plus 5,500 plus 100, the total is 4500, 45400, okay. Now one next we calculate the replacement cost. Replacement cost means if we the cost which is used in future, okay, to replace or that repair that or replace that things or that instrument or that engine, okay. So let's say we know for 13,900 is the boiler and steam turbine is uh, life cycle is 10 years. Then after 10 years, for replacing that steam engine, boiler and steam engine, steam turbine, what amount we need, okay, that is the replacement cost, okay. So that replacement cost, how can we calculate that? From this formula, let's see here. This is the present worth, Pn equal to Sn. Sn is future worth of the money by 1 plus I is interest of the interest for year 1 year, and n is the number of year, okay. This is the future worth of money, Sn, okay. And we also calculate here the future money, that means after 10 years, okay. That or let's say uh, whenever we replace, let's say in today in 2021, the first machine A, okay, let's say with one machine which is A, okay, is priced at 50,000, okay. So but after 10 years, let's say 10 years, okay, after 10 years, let's say 2031, that year that machine A is not 15,000, okay, it may be 16 or 17, is it higher than the present worth, okay. That means the present this is called future worth, okay. And that future worth, okay, is always greater than the present worth, okay. So how to calculate that future worth? By using this formula, okay. This Sn equal to P into Sn by 1 plus I by n. Here you see, here also this is what? This is Sn, okay. This is the future. We want this amount to replace after 10 years, okay. We want this amount to replace after 10 years. So present worth is, we convert that future worth into present worth, okay. So 1 plus 0.1 into the 10, okay. Similarly 5,500 this, 10,000, 1,000 this, and 1,000 this 5 year, then 1,000 this, okay. So total is 8725.4, okay. Now maintenance cost also there, okay. For maintenance cost we want 1% of the total cost, total capital cost per year, okay. So which is 38 3865.15, okay. Now therefore the life cycle cost per kilowatt, okay, this is the formula. Life cycle cost formula is, remember this, capital plus replacement cost plus maintenance cost, okay. So here capital is our 45400. Okay, then replacement cost is there is this, and the maintenance cost is this. Okay, now total this is our life cycle cost. Okay, per kilowatt. Okay, now here capital cost, this capital cost, this capital cost, okay, is equal to the present worth. Okay, so which is 45400. Here it's 45400. Okay, so remember this, the capital cost or capital cost is always the present worth. Okay, now then present worth formula, Pn equal to Sn by 1 plus I n. Okay, now then then calculate annual life cycle cost. Okay, annual life cycle cost, which is ALCC. The formula is ALCC, which is equal to LCC, that is life cycle cost. Okay, and divided by 1 plus f by I minus f. This is the formula. Okay, so here f is the inflation rate. Okay, I is the interest rate, f is the inflation rate. So what is inflation? Okay, what is inflation? Inflation is an increase in the amount of money necessary to obtain the same amount of product before inflated price was present. Okay, that means inflation is that increase of increase in the amount of money. Okay, that means that much money should be increased, which is needed for uh, getting the same amount of product which is buying that. Let's say uh, for with example we can understand this. Okay, let's say 1 kg 1 kg potato, sorry, 1 kg. Okay, sugar, first let's say sugar. Okay, 1 kg sugar price now is 40 per kg. Okay, now it is price 40 per kg. Okay, but after 10 years that price, let's say 50 per kg. So now we can get 1 kg at 40 rupees, but after 10 years we get 1 kg at 50 rupees. Okay, 1 kg at 50 rupees. So this 10 rupees should be increased. Okay, 10 rupees should be increased in the money to get the that 1 kg from or get the 1 kg before inflated. That means this 40 to 50 is increasing of 40 to 50 is inflated money. Okay, so before inflated money we get also 1 kg, and after inflated money we also want that 1 kg. So this inflation, this increase of amount of money necessary to get the same amount of product before and at present. Okay, that increase is called uh, inflation. Okay, remember, that's all. Thank you.